all right, if this is our message type, and we've seen that that's the type of message, and then we've seen that model also we've given a type alias, what's the type of update? This is the type of update. Update takes a message and a model and returns a model. Now, if you're like me, the first time you saw a type annotation like this, you thought, that looks weird. That doesn't look like that's what it's saying. It looks like it's saying it takes a message and then returns a model and then returns another model. What's going on there? Why are there two arrows there? Shouldn't it be something like message comma model? So I thought this was very weird until someone explained to me why it is that way. And then afterwards I was like, oh, that's really cool. Not only do I understand this now, but I actually think this is how it should be, and any other way would be weird and a misrepresentation of what's actually accurate. So I'm going to explain what was explained to me, and we'll see if you have the same reaction. Okay. So Elm REPL is a nice tool for messing around with things and sort of playing around with stuff. It's a read eval print loop. And if you've never used a REPL before, basic idea is you put in an expression, such as, let's say I want to call our pluralize function, passing leaf, leaves, and 3, and it just prints out the result. So in this case, 3 leaves. Also in Elm REPL, there's a nice little feature where it will tell you the type that it returned. So because Elm does type inference, it's like, hey, I know the answer to that, so I'm just going to let you know not only what the value is, but also what that value's type is right there in the REPL. So if I call pluralize leaf, leaves, and 3, comes back with 3 leaves as the answer. I can also just put a plain function in there, and Elm REPL will just say, well, here's the type of that function. So in this case, it takes a string, and then another string, and then an int, and returns a string. And there's that syntax again with all the arrows. Okay. Now, here's an interesting question. What happens if I put in pluralize leaf and leaves? Well, if you remember from earlier on in the workshop, we discussed partial application. So when you call an Elm function and you leave off an argument, Elm says, oh, you're not done calling this function yet, so I'm not going to execute it yet. I'm not going to pass undefined or anything like that, because we don't have undefined. What I'm going to do is I'm going to say, okay, you gave me this function. You gave me 2 out of the 3 arguments. What I'm going to give you back is a function that takes the last argument and then finally finishes the job and returns the thing that the overall function returns. So that's partial application. Okay, so the first thing makes sense to us. Obviously, if you pass all the arguments, it gives us back a string. Also, the last thing, I think more intuitive than the middle thing in the sense that if I call it passing 2 out of 3 arguments, it's going to give me back a function that clearly takes an int, which is the final argument, and then returns the string that is the result of finishing the job. So how do we get, how do we square those with that middle thing, where the multiple arguments have the multiple arrows? Okay, well, let's kind of like think about what we know and like what we've observed in a little bit of a different way. So we're calling pluralize passing leaf, leaves, and 3, and that gives us back a string. And we've also established that if you call pluralize passing just leaf and leaves, and leaving off the 3, that gives us back a function that takes an int and returns a string because of partial application. Now another way we could write this out is we could put parentheses around this. That's fine, right? I mean, parentheses are essentially harmless in this case. We're just saying, I want to put parentheses around that expression. That's legit. Another way we could do this is we could put the parentheses down there and also add a 3 on the end. So this is essentially we've taken the previous one and said, oh, well, what's in those parentheses is a function from int to string. So let's take that function and give it an int. Well, sure enough, that'll give us a string. And actually, if we look at this, we can see the bottom one and the top one are basically the same. I mean, all we've done is we just added some parentheses. So the first and third example here are really the exact same thing. It's just, in both cases, we are taking pluralized leaf and leaves and then giving it a 3. We get the same answer either way, with or without the parentheses. Okay, so let's just get rid of one of them so we can just kind of see things in this way. All right, what happens if we give it only one of the 3 arguments? Well, the way partial application works is that anytime you partially apply a function, however many arguments you leave off, that's how many arguments the resulting function is going to take. So if we call pluralize just passing leaf, it's going to give us back a function which takes a string and then returns a function that takes an int and returns a string. So we can see that in action by adding some more parentheses down here and say, okay, what happens if I call that thing in this way? Well, if I take this, it's a function that takes a string and returns a function that takes an int and returns a string. Is that true? Well, yeah, we can see that from the example down below now that I've added additional parentheses. if I take this exact function and I give it a string like it asked for, well, sure enough, what I get back is a function that takes an int and returns a string. And if I take that and all those parentheses and I give it an int, well, then sure enough, I get a string. So we can start to see a pattern develop here. Each time we partially apply it one more, if we give it one more argument, it gives us back sort of the next thing in the triangle here. Let's take that one step further and not even partially apply it at all. Let's just give it 0 arguments. Well, to continue the pattern, now we're like, okay, well, give me that very first string, and I will give you back the next thing, which is to say a function that takes a string and returns a function that takes an int and returns a string. So now we've sort of like built it all the way up. And as we can see, in each of these cases, when we give it one more argument, all we're doing is partially applying it one more time and getting one more specific function until eventually we run out of functions and we're left with just a string. And what if I told you that when I just have pluralized by itself, you just don't need those parentheses in the type annotation? So the reason that we annotate it like this is essentially that either of these is perfectly valid. And in fact, if you want to annotate your types like this, Elm will allow it because it's accurate. It's just that this looks nicer, so people tend to do it without the parentheses. And they mean the same thing. So that's why this is sort of the canonical way of writing this. But it's actually also really the only accurate way to write it, because this actually is what's going on. It really is true that pluralize is a function that takes a string and returns a function that takes a string and returns a function that takes an int and returns a string. It's just that the way that Elm calls it, it's sort of masking that by making it look as if it's actually a function that requires 3 arguments and takes 3 arguments. But when we start to look at what happens when you partially apply it, we can kind of see the truth, which is that really, essentially, every Elm function really only takes 1 argument. It's just that quite a lot of Elm functions happen to take 1 argument and then return another function, which possibly takes 1 argument and returns another function. But the syntax makes it nice so that you have the ergonomics of calling with multiple arguments while still having this nice guarantee under the hood that partial application just works consistently across the board. In summary, that's why updates type is this. Message, a model, and a model. Okay, to sum up, we talked about type annotations. So we talked about record annotations, primitive annotations. We can see int, bool, and point, which is a record that has both. We talked about type parameters, parameterized types. We talked about like list string, which is to say a list of strings. And we talked about HTML message, which is to say some HTML that emits a message of that particular type when the user interacts and sends that type of message to update. We talked about how it's really important that those agree, and if HTML is parameterized on a different type than what update expects, then it won't compile because those need to be consistent. We talked about type aliases, which is a way to give a name to a particular type so that we can break our types down into different named things rather than having to glom them all together when we have complex records. And finally, we talked about how to annotate functions, which is to say, annotate them based on partial application. If they have multiple arguments, then we're going to represent that honestly by showing an arrow in each case, because essentially every Elm function really only has 1 argument. It's just that sometimes it returns an additional function.